Hello and welcome to Saxon Math. This is lesson 67 using prime factorization to reduce fractions. One way to reduce fractions with large terms is to factor the terms and then reduce the common factors. To reduce 125 1,000ths, we could begin by writing the prime factorizations of 125 and 1,000. Recall from previous lessons that we used a factor tree, which you'd have 125 at the top and create some factors that can multiply out to that. So for example, like 5 and 25 will go into that. This would be a prime number. This is not a prime number. That's a composite number that can be broken down into two other prime numbers. So we can see that 125 is a makeup of 5 times 5 times 5. Those are the prime factors of 125. You can do the same for 1,000, but let's say we did it using division by primes. So 1,000 divided by 2 is 500. 500 divided by 2 is 250. 250 divided by 2 is 125. 125 can be divisible by 5, which would result in 25. 25 divided by 5 equals 5, and 5 divided by 5 equals 1. So these would be the prime factors of 1,000. If we were to multiply 2 times 2 times 2 times 5 times 5 times 5, you get 1,000. So using those terms, now you can list those in the numerator and these in the denominator. So the factors of 125 mean that 5 times 5 times 5 is the same thing as 125 in the numerator. 1,000 being in the denominator, you can have these factors representing 1,000. Once you have this set up, now you can see that the pairs of 5s that can be reduced, each 5 over 5 would reduce to 1 over 1. So this 5 and this 5 reduces to 1 over 1. This 5 over this 5 reduces to 1 over 1, and this 5 over this 5 reduces to 1 over 1. What you have then is this, which is simply going to result in 1 times 1 times 1 in the numerator, and 2 times 2 times 2 times 1 times 1 times 1 in the denominator. You'd end up with 1/8 as the final answer. So 125 thousandths will reduce to 1/8. So the two stages or strategies for finding the prime factorization of a number, factor trees, or division by prime. And we did both of those here. All right, let's try an example. So reduce 375 1,000ths. Now you have to start with 375. I'm going to use 375. I like division by primes because I can see clearly it's going to be divisible by 5. 5 will go into 37. It will go in there 7 times, which give me 235. That would be 2 away, and that makes 25 divided by 5. That'd be 75 here. So 75 is the answer to that. Now I can see that this is divisible by 5 as well. 7 divided by 5 would be 1. That would be 2 away from 7 because 5 taken away from 7. Now I have 25 divided by 5 equaling 5. So the answer to 75 divided by 5 is 15. 15 is also divisible by 5, and it results in 3. And 3 is divisible by, the only prime number that it's divisible by is 3. And we end up with 1 in the top. Now that I have these, I know what 375 is. It is 3 times 5 times 5 times 5. You can use what you remember from 1,000 from the previous page, or we just do it again here. 1,000 divided by 2 is 500. 500 divided by 2 is 250. 250 divided by 2 would be 125. 125 divided by 5 equals 25, and 25 divided by 5 equals 5. 5 divided by 5 equals 1. So now I have 2 times 2 times 2 times 5 times 5 times 5 as the denominator. I'm going to make each of these, so this would cancel that out. That'd be 1 over 1. This would be 1 over 1. This 5 would cancel this 5 out, so that'd be 1. All that you have left is this 3 times, so what you have here is 3 times 1 times 1 times 1 in the numerator, and 2 times 2 times 2 times 1 times 1 times 1 in the denominator. So what you have is 3 times 1 makes 3 in the numerator, and 2 times 2 is 4, 4 times 2 is 8, and 8 times 1 times 1 times 1 would be 8. So the answer to 375 1,000ths as a reduced fraction is 3/8. We can write the prime factorization of both the numerator and the denominator and then cancel it out. When we reduce these common factors, you can see that they're just left with 1 over 1. So you do have to remember that you're basically turning this 5 over 5. It's a 5 over 5 equaling 1 over 1. It's an equivalent fraction. They both equal 1. So that's what you're doing there. Anytime you find the same number, we did not find 3 down in the denominator, so we couldn't cancel that out. There was no 2 in the numerator. There was no 2 for this one in the numerator. There was no 2 in this one for the numerator. So all you're left with is 3, and then you remember this was 1, 1, 1. This turns into 1, 1, 1 because there's one of each of those. Okay, if there was only 2 5s up here, you would have 1 5 remaining down here. It has to match up. You have to correlate top and bottom. All right, so let's write the prime factorization of both the numerator and the denominator of each fraction and then reduce the fractions. So for letter A, I'm going to start with 875, and I'm going to do division by primes. I know that it's divisible by 5 because it ends in 5. So this 5 will go into 8 one time. That'll be 3 away from there. So this would be 37 divided by 5, which would be 7. That would get me to 35, which is 2 away. 25 divided by 5 is 5. So it's 175. This divided by 5, the closest I could get to that would be 3, sorry. So this would be 3, which would get me to 15 and it'd be 2 away. 25 divided by 5 would be 5. 35 divided by 5 I know is 7, and 7 divided by 7 is 1. These are all the prime factors of 875. So it would be 5 times 5 times 5 times 7 in the numerator. And the denominator is going to be, if you guys remember these patterns with 1,000, 10,000, it would be the same. We have 3 2s, because remember it was 3 zeros there. 3 2s and 3 5s. You guys remember that pattern from the previous lesson? If it was 10, we had 2 times 5. If it was 100, it was 2 times 2 times 5 times 5. And when it's 1,000, it's 2 times 2 times 2 times 5 times 5 times 5. So, and if you don't remember that, you just simply have to do division by primes, which might look like this again. 125 divided by 5 is 25, and then you got this 5 divided that 5, and you're left with that. So you see, you can work it out that way. So this is 875 in the numerator. This is 1,000 in the denominator. This is an equivalent fraction essentially with prime numbers only. Once you've got the prime numbers in the numerator and the prime factorization in the denominator, now you can start canceling things out. So I can see that this 5 cancels out one of these 5s. This 5 cancels out one of these 5s. This 5 cancels this 5 out. There's no 2 to cancel out up here. There's no 7 down here. So all I'm left with is 7 in the numerator and looks like 8 in the denominator, because 2 times 2 times 2 is 8. So 7/8 would be A. All right, for letter B, when you're doing this one, it's 48 over 400. So again, you need to do prime factors of 48. I'm going to start with the division by primes again. 2 will go into that 24 times 24, 12, 2, 6, 2 again, 3, 3, 1. So that means the numerator for 48 is going to consist of 2 times 2 times 2 times 2 times 3. That's the numerator equivalent for 48. For 400, I'm going to divide that by 2. I get 200. This one will be divisible by 2 for 100. This would be divisible by 2 for 50. 50 would be divisible by 2 for 25. 25 would be divisible by 5. And 5 would be divisible by 5. So now I have the denominator. It was 2 times 2 times 2 times 2 times 5 times 5. And this one should open up. You should be able to see this really clearly. This 2, this 2, this 2, this 2. Numerator, denominator, numerator, denominator. All that's left is 1 times 1 times 1 times 1 times 3, which equals 3 in the numerator. And all those 1s times 2 5s there be 25. That will be a reduced fraction. The beauty of this is if you're using the correct prime factors as the numerators and the denominators, you've reduced that fraction completely and wholly. So this equals 3/25 as a reduced fraction. This one was 7/8. All right, let's do letter C. For letter C, 125 500ths. So to get the prime factors of 125, I'm going to do division by primes again. That'd be 5, 25, 25 divided by 5 is 5, 5 divided by 5 is 1. So the numerator of this is going to be 5 times 5 times 5. The denominator is going to be 500. It looks like I could divide that by 5. I'd get 100. And 100 divided by 5 would work as well. I'd get 20. 20 would work. 20 divided by 5 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. So the denominator is going to be 2 times 2 times 5 times 5 times 5. Now in order to reduce those, I can see that this numerator's got a 5 in it, and there's a denominator here with the 5. Numerator with a 5, a denominator with 5, numerator with the 5, denominator with the 5. All I'm left with is these two, and this is 1 times 1 times 1. So the numerator in this case is going to be 1. The denominator will be 4. So 1/4 would be the answer to that reduced fraction. And then letter D. So for letter D, let me just put that right here. If we have 36, I'm going to do division by primes. 36 divided by 2 would be 18. 18 divided by 2 would be 9. 9 divided by 3 is 3. 3 divided by 3 is 1. For 81, I know that that's divisible by, well, I know it's divisible by 9. And 9 is divisible by 3, so that probably means that I can divide this by 3. 3 will go into 8 2 times. That'll get me close to it. It'll be close to it, 2 away from it. 21 divided by 3. So this would be 27 the way it looks. And 27, interestingly enough, is a prime number in itself. So that is done. 27 is a prime number. So that means for our numerator, we'd end up with, sorry, let me go back. 27 is not. 27, we could actually divide by 3, which would be 9, and 9 divided by 3 would be 3. 3 divided by 3 would be 1, so I guess we'd end up with this. 9 times 9 makes 81. That's more accurate there. So in this case, we have 36 equaling 2 times 2 times 3 times 3 in the numerator. The denominator is going to be 3 times 3 times 3 times 3 in the bottom, and all you have to do is match them up. So in this case, I see that there are no 2's in the denominator, so those 2's will remain. I'm just going to put a box around them. This one, we could cancel out any one of those 3's. Let's just use this one right here. And this 3 will cancel that 3 out. So all we're left with down here is 3 times 3, and up here we've got 2 times 2, so that'd be 4/9, because 4 times 1 is 4, and 3 times 3 times 1 is 9. So 4/9 would be the answer for letter D. 36/81 or 81st would be 4/9. All right, excellent work today. Make sure you guys go and do your lesson written practice 1 through 30 in Saxon math. Remember, 1 through 30, no doing 1 through 15 or 16 through 30. You must complete all of your Saxon math problems in order to get the practice from previous lessons. That's the only way Saxon math works. All right, have a great day, and we'll see you tomorrow.